Yeah, so with this one here, you could change this into cos squared, but you can't change this up top into cos to the fourth. That's not an identity or a manipulation for a given identity. So what you might want to do here is multiply top and bottom by the conjugate. So that's a very good thing to do. Top and bottom by the conjugate. Now the conjugate is the same terms, just opposite signs, because that is going to yield you on the bottom. It's going to yield you a difference of squares, right? So this is actually going to equal. You're going to have 1 minus sine to the fourth theta. Okay. And then up top. Okay. So one. Okay. Now up top, you have to be careful. You don't want to expand this out on top. You don't want to expand this out because watch, we actually have a common factor that we can divide out from the top and the bottom. All right? So remember, like I said before, in the denominator especially, when you multiply top and bottom by the same thing, sometimes you want to expand to simplify, but a lot of times you want to leave factors alone so that you can see that there's a factor on the top and a factor on the bottom that can be divided out. And here's the case where I would not expand this because what do we see? We see this factor on top and this factor on the bottom going away, right? They divide out to 1. What you're left with is this. And this would be a reasonable substitution, okay? Because this is one of your identities, a form of your identity, and 1 minus sine squared, of course, does equal cos squared theta. So there you have it, there and there. You're done. Quod erat demonstrandum. We have demonstrated that which was to have been demonstrated. Okay? Are there other ways to do this? Yep, there certainly are. As I mentioned, you could go ahead and change this one into cos squared right away. Then you'd have to factor the top, and that would be fine as well. Okay, but that would be longer.